So let's start addition reaction. What is addition reaction? Some molecule like HBr getting added to a double bonded compound. We are getting hydrogen getting in one side and bromine is getting added in other side. So that way we are getting the addition reactions. So what is a double bond? Double bond means one sigma bond and one pi bond. So here there is a full of electron density. Above and below there is a pi electron density, pi electron cloud. We can call it electron cloud. And this thing particularly I prefer to tell this that electron density is evenly distributed over here. I use the term very frequently. This is evenly distributed. Evenly distributed. The charge over here, electron density here is evenly distributed. Means equally distributed both the carbon, over both the carbon. Carbon 1, carbon 2, over both the electron density is equally distributed. It's called evenly distributed electron density. So that is called nonpolar. Nonpolar means evenly distributed electron density. Nonpolar not explaining things, but evenly distributed electron density is explaining the thing. That's why I prefer it. Okay. Now, carbocation is coming or any type of electron deficient species, electrophile that is approaching easily can enter here because electron density is available and electrophile is seeking the electron density. So it can easily enter over here. So the reaction starts that way. First H plus getting added because electron density is full. So H plus can easily penetrate there. It can accept the electron density and making the bond. So that is the starting of the reaction. And we are getting carbocation. Getting carbocation intermediate. And after that, maybe Br minus is getting added. So we are getting HBr addition. First H plus addition followed by Br minus addition. So we are getting HBr addition. This is called addition reaction. And what are the attacking reagents? Electrophiles, CH3 plus, Br plus, H plus, H3 plus, all are plus charge things. And neutral electrophiles can be LCl3, BF3, FeCl3, SO3. But these things are, when these are reacting, these are actually acting as catalyst, not a permanent, forming a permanent product. Acting as a catalyst, carrier, catalyst. But SO3 can act as a reactant. SO3. It reacts like the benzene sulfonic acid. Benzene plus SO3 giving you benzene sulfonic acid. SO3H group on the benzene. And these things are, no, see here, these are metal. Na? So metal and this, it is not always making, not always, sometimes it can make, but most of the time they are not making permanent bond molecule with the carbon compound, in the carbon compound. Because these are acting as catalyst. They have vacant orbital, we are utilizing them. Like Friedel-Crafts reaction, LCl3 is used as a catalyst. Okay. Now BF3, LCl3, these are Lewis acids. We are using them for reaction, but practically they are not making a permanent product. Okay. So why these are metal and non-metal? Metal-non-metal reaction possible, is not impossible. Like Grignard reagent. So there it is happening, but not always. These things we are usually using as a catalyst. FeCl3, what is the use? What is the use? Chlorination of benzene, suppose. So you are giving chlorine, benzene, chlorine and FeCl3. You are getting chlorine. But what is the role of FeCl3 there? Carrier. Yes, carrier, catalyst, that type of role. They are not reagent directly. Lewis acid we are using for that purpose. They are acting as catalyst or carrier. And here structure of alkenes. I don't need that much of detail record. Okay, just you consider this. So this is what? Hydrogenation of alkene. This is a very common reaction. Ethylene plus ranitidine and hydrogen gas, you are getting ethane. Practical application, you have unsaturated fats. Okay, oils and fats. Unsaturated molecules are present in that, and if you do the hydrogenation, the vegetable oil can be converted to vegetable ghee, dalda. So that type of conversion, visible changes, easily can be done. Okay, if you do the hydrogenation of this oil, it becomes that lump of fat in front of you. So it happens. So saturation, unsaturated compound is becoming saturated. Vegetable ghee, dalda. Vanaspati, luchi bhaja dalda. Luchi bhaja dalda. এখন আর ইউজ হয় না। তো আমাদের ছোটোবেলা দেখেছি, এখন আর নেই। এখন মার্কেটে আছে পাম অয়েল, পাম তেল, যেটা আরও খারাপ। বড় বড় ডালডা বোতল ছিল, ব্যারেল ছিল, কৌটো কৌটো। Okay, so hydrogen is now alkene. So this is application I am telling. So everywhere try to impose some application. Otherwise you will think what to do. इसको सीख के करेंगे क्या? So everywhere there is a application. Just think over it. So here, if you have a Bonaspati dalda that changes that you are doing, so sometimes it is required. You are doing that type of reaction. So then how do you are doing it? Nickel, platinum, catalyst. Ajay, but any idea how nickel or platinum can be used as a catalyst? How it is acting as a catalyst? What is the mechanism? Probably you are not clear. Huh?
Reactivity is quite less.
No, but fine. Then it will not react. It will be aloof. How it is enhancing the reaction? It is acting as a catalyst means it is helping the reaction some way. How? That mechanism probably you don't know. Think over. Okay, I'll tell you. Suppose this is the surface of a platinum. Try to understand everyone. Suppose this is the surface of a platinum. Now, whenever just you look at here in this molecules, so platinum molecules on the surface, they are not getting bond outward. Okay, those who are in the bulk, they are making 4-4 bonds because it is tetracovalent. Nickel or platinum, they are tetracovalent. So they are making 4 bonds. But what about those on the surface? They have no other molecule outside, so they are getting only 3 bonds. Isn't it? So one bond is missing. Those who are on the surface, practically they are not getting 4 bonds, 3 bonds they are making, but what about the 4th one? Not done. So that's why they are always unhappy, not satisfied, dissatisfied. So they are looking for some sort of, so that is called surface energy. This phenomenon is called surface energy. So always surface energy is active. Are you getting me? Surface energy is becoming active because they are making 3 bonds, not 4th bond is not becoming possible. So what is happening when hydrogen gas coming in contact or any such gas coming in contact, it is capturing the hydrogen. कुछ नहीं मिल रहा है तो हाइड्रोजन ही आ जाओ, कुछ नहीं मिल रहा है तो हाइड्रोजन ही आ जाओ, कुछ तो बॉन्ड बनाना है, किसी को नहीं मिल रहा है तो कोई भी आ जाओ, ब्रेन फ्रेंडशिप करेंगे, तो हाइड्रोजन जाके उसके ऊपर बैठ गया, चलो ऐसा करके बैठ गया. Now hydrogen was a molecule, now it is becoming atom, atomized hydrogen on the surface, attached to the surface. It is called chemi-adsorption. Okay? Hydrogen atomized. Now this atomized hydrogen getting attached to the surface of platinum in the form of hydrogen atom in like this way. So it is attached to nickel surface or platinum surface like this. But it is atomized and is highly reactive. But this bonding, hydrogen and platinum or hydrogen and nickel, it cannot be a strong bond. Very, very labile bond, flexible bond. Whenever it is coming, something better is available, so hydrogen is leaving the surface and going there. इसके साथ उसका कोई लेना देना तो है नहीं ज़्यादा, तो जहाँ उसका एक्चुअली फ्रेंडशिप है उसका चला जाएगा उधर. कुछ नहीं मिला तो उसके साथ है, जो भी कुछ बेटर मिल जाएगा तो छोड़ के चला जाएगा. ऐसे ही होता है ना दुनिया में, तो उसका भी उधर भी ऐसे ही हो रहा है. बेटर मिल गया तो चला जाएगा उसके साथ, इसके साथ उसका जमता नहीं है, जिसके साथ जमता है उसके पास चला गया. बॉन्डिंग अच्छा नहीं था, खोल के निकल गया. अच्छा, निकल के गया कहाँ? एल्किन के साथ, क्योंकि उसके साथ उसका फ्रेंडशिप अच्छा होगा. क्यों? क्योंकि कार्बन कंपाउंड्स दे आर कार्बन का व्हाट इज द इलेक्ट्रोनेगेटिविटी ऑफ कार्बन 2.5 एंड व्हाट इज द इलेक्ट्रोनेगेटिविटी ऑफ हाइड्रोजन 2.1, वेरी क्लोज. तो अच्छी फ्रेंडशिप जमते हैं. हाइड्रोजन के साथ काम करके देखो हजारों बॉन्ड मॉलिक्यूल है, मीथेन है, इथेन है, प्रोपेन है, ब्यूटेन है, कार्बन हाइड्रोजन बॉन्ड, हाइड्रोकार्बन सीरीज. तो whenever it is coming in contact of ethylene or propene, something like that, so hydrogen is releasing, just leaving behind platinum and directly getting attached there so easily from the same side and getting attached so easily, and platinum is left behind again. So it is acting as a surface, and that surface is helping the reaction, but practically this platinum is not changing anymore, and this is called chemi-adsorption. When the atomization is taking place and getting attached on the surface, this is called chemi-adsorption. Another way that is happening, it is called physisorption. Palladium. Palladium is not like that. Palladium has got a lot of cuts and cracks on the surface. Holes and cuts and cracks on the surface. Pores. And hydrogen gas is seeping through, entering all these holes, filling the holes. That is called physisorption. Filling the holes, but actually no bond. That is called physisorption. So these two principles, either chemisorption or physisorption. Chemisorption is occurring on platinum nickel and physisorption occurring on to palladium. That's why a piece of palladium can absorb lot of hydrogen because palladium has pores. Nickel platinum has not that much of pores. I understood what you are trying to ask. Palladium has got no pores, ulta. Platinum and nickel has got no pores that way, not cracks and holes. But palladium is a porous metal. It has got a lot of holes inside. That's why it is sucking the hydrogen and entering into it. And why? Because the holes can be filled up better by hydrogen. Why? Again, air is heavier and hydrogen is lighter, so it can fill up the hole there quite easily and making some sort of flexible bonds inside the hole. It is replacing air. Hydrogen is entering and replacing the air. And whenever you are applying heat, the hydrogen comes out. So palladium absorbs a lot of hydrogen, apply heat, that same hydrogen comes out. Okay, that's why palladium also acts as a catalyst. Is a supplier of hydrogen, absorbing hydrogen, and whenever required is releasing hydrogen. So it's a supplier of hydrogen. And nickel platinum, that is also a supplier, but in a different way. It is first of all making the bond and then losing the bond. Got it? The Markovnikov addition rule. Negative part of the addendum is getting added to the most substituted carbon. If you take some olefin or alkene, alkenes are also called olefins. Olefins or alkenes, the negative part of the addendum is HX. HX. X is the negative part and H is the positive part, so HX. Just to make it generalized, we call it HX. So X minus is getting added to the most substituted carbon and H is getting added to the less substituted carbon. So this is called Markovnikov product. And when the opposite occurs, it is called anti-Markovnikov product because the mechanism altogether is different. In this case, this HBr addition in aqueous medium, it is happening in polar medium and we are getting Markovnikov product, ionic mechanism. Here it is ionic mechanism. But here, when radical mechanism is taking place, apply heat. Already told you yesterday that apply heat or light. Peroxide, obviously. Peroxide is there. Here, this is the peroxide. But along with peroxide, you need to further provocation. I can tell it provocation. Two further provocations required. One is called heat, another is called light. Either that light should be scattered sunlight, which is full of ultraviolet radiation. And ultraviolet is higher energy. That's why it breaks the peroxide easily, making it this RO dot. This RO dot is initiator. This is the initiator. It initiates the reaction. And after that, this RO dot is accepting one hydrogen, producing Br dot. That Br dot is radical or atom, with atomic state bromine is much more reactive, so it starts the reaction. Getting added to the this side and or this side. There are two possibilities. Either bromine will be added here or here. If it is added here, then you are getting 2 degree radical, secondary radical. But if it is added here, just a second. If it is added here, then we are getting 1 degree radical. And 2 degree radical is preferred compared to 1 degree. Why? Because of hyperconjugation. Already I have explained what is hyperconjugation. So, because of more alpha hydrogen that is you are getting, if the radical is formed. Okay, I think I stop it here and show it in the board. This particular part.